Let's talk about these two. The one on the left, even or odd? Even. You know that because? Yes, the ends, the left and the right side, are both pointing down. Would it still be even if they both pointed up? Yes. Good work. Leading coefficient, positive or negative? Negative. We only care about one side when it comes to the leading coefficient. Which side is that again? Right side. Zeros. How many x-intercepts do you see? 4. What are they? 0, 0, 3, 0, and 5, 0. All right, we are going to write a possible equation. Has to start with what? Y equals f of x equals h of x, something at the beginning, and then an equal sign. If there is no equal sign, you didn't write me an equation. Let's see. Today is right before break, so I'm going to call this one b of x, just for funsies. After my equal sign, what do we have to see?
Negative number.
Some kind of negative number. Does it matter what kind of negative number we pick for this? No. Later on, if you take pre-calculus, you will learn how to find that exact value. But right now, I just want to focus on, is it positive or negative? And we get some freedom with that. Okay? So as long as I see a negative number after the equal sign, we're good. What negative number do you guys want to put there?
4.
Negative 1 is the first thing that I heard. Negative 4 is perfectly fine. If you choose negative 1, you can put just a negative sign there. You can put in the actual 1, but you don't have to see the 1. Remember, 1s are allowed to be invisible. The negative sign is never allowed to be invisible. And now I need to do my factors. I have some zeros. How do I take it from being a 0, like here, x equals negative 2, and turn it into a factor? I need to make it equal to 0. So for this one over here, if I need this to be equal to 0, what would I do? Add 2 to both sides. Now I've got it equal to 0, and this is my factor. So inside parentheses, x plus 2. We have a 0 right here. What is the x part of that ordered pair? 0. It's already equal to 0. I don't have to add or subtract things to both sides. So this, all by itself, is a factor. So I have x. I'm going to run out of room. Oh, well, I'll shrink it down. What would it look like for this one? What would my factor be? X minus 3. Because x minus 3 equals 0 when I set it equal to 0. And what about my last one? X minus 5. I'm going to shrink that down so that we can all see that instead of it running into those words there. There we go. So some kind of negative number after the equal sign. Does it matter what order you put those factors in? Nope. I just need to see all 4 of them. Did we say this was an even function or an odd function? Even. Do you remember when we talked about each of these parentheses having a power on it? We talked about it very briefly yesterday. We're going to talk about it more today. If you don't see an exponent on something, it's understood that the exponent is what? 1. So even though I don't see it, each one of these has a power of 1 on it. If I add those exponents together, it should tell me the degree. 4. Is 4 an even number or an odd number? Even. So that matches what we said at the beginning about whether this was an even or an odd function. Let's go do the one that's on the right. Is that even or odd? Odd. And you know that because? Ends are going opposite ways. Leading coefficient? Positive. We look at the right side for that, the right end. How many zeros are there? 3. What are they? -1, 0. 2, 0. And 4, 0. All right. We're going to write a possible equation here. I used b of x for break. It's Thanksgiving break, so I'm going to use t of x for this one. You can use y if you want to. I don't care. Right after the equal sign, what do we need to see? Positive number. What positive number do you guys want to use? 1. Sounds good. If it's a 1, do I have to put anything there? Nope. So then I just start in with my factors after that. What are my factors? I know I'm going to have 3 because I have 3 zeros. X plus 1, x minus 2, x minus 4. Yeah. The exponents on there, each of them has a little 1. And so I add those up, and I get 3. 3 is even or odd. So that matches what we said back at the beginning. So now I know I'm good. All right. I want to practice with 2 more problems like this, and then we're going to learn how to go the other way. When they give us an equation, we could sketch, not formally graph, no tables, but just sketch a very basic graph. Okay? So page 270, 270. I want you guys to decide about the degree and the leading coefficient up at the top, and then do part C and D. Hold off on domain and range, and please hold off on the equation for right now. Even if you're pretty sure you know how to write it, hold off on the equation for right now. So I want you to do degree and leading coefficient, end behavior, and zeros. Take a moment to do that on your page. Even or odd? Odd. We know it's odd because why? Ends are pointing opposite ways, yes. Positive or negative leading coefficient? Positive. We know that because right side points up. I asked you to hold off on domain and range. We're going to look at it right now. I wanted to do it together. There's only one kind of function that we've studied this whole semester where the domain was not negative infinity to positive infinity. It's the one that we just took a test over last week, square roots. Square roots started at 0, 0, and then went off to the right. Does this do that? Then it's negative infinity to positive infinity. My graph keeps going to the left, and it keeps going to the right. There's nowhere on there that I just see on the left or the right, it all of a sudden comes to a halt. I mean, I run to the edge of my graph, but if I could zoom out on the graph, that red squiggle would keep going. Range. What am I looking at for the range? The y's. We always start with the smallest value, so I'm looking down. Does one end point down? Yes. So is there a smallest y? Negative infinity. Keeps going down forever. Then I want my maximum next. What's the highest this graph ever goes? Infinity, because it keeps going up, right? They didn't draw the arrows on here, but it just runs right off my graph. Sometimes you'll see the arrows, sometimes you won't. If it goes all the way to the edge of the graph and there's not like a point stopping it, we assume it goes on forever. This is my range for all odd functions. Why would that be my range for all the odds? Yeah, the odds have this same behavior where one end always points down forever, and the other end always points up forever. End behavior. I have to decide which one of these is the left, thank you, sir, and which one of these is the right. How do I decide which one means left and which one means right?
Because the right is understood.
Yeah. X with an arrow and the infinity sign without the negative in front of it. Positive numbers are found on the right side of the x-axis. Negative numbers are found on the left side of the x-axis. So the first part of this math sentence is just telling me which side to look at. As x approaches negative infinity, as I look on the left side of the graph, what is the graph doing on the left? Going down. So I need f of x, because I have to explain that I'm talking about the graph now. So I'm going to use function notation. How do I explain it's going down? Negative infinity. What should the last part of this next sentence be?
Just infinity.
Just an infinity sign? Like this? What else do I need other than that? I need the f of, why do I need the f of x? So when I look at this, I read it almost like a sentence out of a book. It's not written in English necessarily, it's written in math. Math is totally a foreign language. As x approaches infinity, as I look on the right side of my graph, infinity. That doesn't make any sense. When I read the sentence up above it, it says, as x approaches infinity, as I look at the left side, f of x, this is my graph. My graph goes to negative infinity. My graph goes down. You have to have something in here that says my graph is doing this, or the graph is doing this. If you don't have that function notation, it's a sentence that doesn't make complete sense. F of x approaches infinity. And again, you can put a little plus sign there if you want to. You don't have to have the plus sign, but if you want to make it really clear that that's a positive infinity, that's fine. How many zeros are there? 2. Where are they? -1, 0, and 3 zeros. So how many factors are we going to have? 2. Let's write this possible equation, and we're going to find a problem that happens here. We're going to talk about how to fix it. So we haven't done anything wrong. I'm going to call this one y equals. Right after the equal sign, what do I need to see? Positive number. What positive number do you guys want to use? 2 is the first thing I heard. Some kind of positive number. I need 2 sets of parentheses. Why 2 sets of parentheses? There's 2 roots, 2 x-intercepts. One of them is coming from here, x equals -1. So what will this factor be? X plus 1 and x minus 3. Do you remember how on the bell work we were talking about every set of parentheses has a little exponent on it? Well, if each of these is a 1, what's my problem? 2 is not odd. 1 plus 1 equals 2, not odd. All right, so look at this graph. This root right here is what's causing the problem. X equals 3, so then I subtract 3 from both sides. Do you guys see how it bounces on the x-axis there? Like a parabola does? If all I could see about this graph was what I have circled in purple, if I cut off all the rest of this graph and you couldn't see it at all, would you think that I had graphed a parabola? No? You don't think so? If I had, like if you couldn't see any of the rest of this, all there was just what's in that little circle there. And I blew it up real big on the screen, you're like, that's obviously a parabola visible. What about if I just looked at the other little circle? If that's all you could see, what would you call that shape? Looks like a line, right? If it looks like a line where it touches the x-axis, it is degree 1. The exponent is a 1. How do we know when we're looking at equations that something is a parabola? What do you always notice about the equation of a parabola? It has an x to what power? X squared. Parabolas always have x squared in them. This right here, when my 0 looks like a parabola, right at the x-axis, this is called a double root. And that means the power there is not a 1, it is a 2. Now what do I see when I add up those exponents? Yes. So 1 plus 2 equals 3. Is 3 an odd number? Yes. So always check your degree at the end. Look at each one of those x-intercepts. Block everything else out right at that x-intercept. If it goes straight through it like a line, we just leave it as the factor. If it's bouncing and it looks like a parabola right where it touches the x-axis, we're going to put a squared on it. All right. I want you guys to flip over to page 271. And we're going to practice doing some sketches here. I have a function in factored form, and I want to sketch this. What would the degree be? We just practiced looking at this. Why is it 2? There's 2 factors. What's the exponent on each of those little factors? A 1. They didn't print any other numbers there. So for my degree, I do 1 plus 1, and I get 2. This is degree 2, and so it is even. Oh, I should have put the even on the other line. There we go.
Can we just put it
Hmm?
in? When they said even or odd, can we just put it in?
Yeah, or you can circle where it says even. I'm totally fine with that also. Oops. Leading coefficient.
Positive.
Positive. How do you know?
There's no negative sign.
There's no negative sign right after the equals. So we're looking right here. This is a positive number. I have factors to work with. How do I find the zeros if they give me the factors?
Do the opposite.
Factors always get set equal to 0. So I take x plus 3, I set it equal to 0. But then I want to get x equals for a 0. So I'm going to subtract the 3 from both sides. X equals negative 3, so one of my zeros is at negative 3, 0. Where's the other one at? 2, 0. X minus 2 equals 0. So I add 2 to both sides. X equals 2. So 2, 0. Talk to me about the end behavior. What would be happening here? What'd you say? Which end can we make a decision about right away?
The right side.
The right side. Which one of these means the right side? Leading coefficient tells me about it, but which one of these two is the right side? Bottom one. This is the right. They already put that f of x on there for me. Nice. Leading coefficient tells me the right side is doing what? Going up. This comes from my positive leading coefficient.
It says even, so both should point the same way, right?
That's exactly right. We said it was an even function, so both ends go the same way. I have all the information I need to sketch this graph now. Where should I put those x-intercepts? Negative 3, 0, so right here, and positive 2, 0. What do we know about our ends? They both go up. So if my ends both go up, what's the rest of this graph look like? It's going to look like a parabola. Look right here. When I go and find the factor that we got that from,
What is that first point on?
what is the what?
That square. I got the square around it.
It's at negative 3. I'm just graphing those x-intercepts, negative 3, 0, and 2, 0. This 0 right here came from this factor, right? What's the power on that? A 1. So when I look at my graph, it's going to go straight through it like a line right there. What about the other one? 1. Straight through it like a line right there. And then I just need to connect them.
Does it matter where you connect them at?
Not for these sketches.
So you can connect because it's a possible equation?
This is the equation, but right now we're just working on sketching as opposed to like formally graphing things. Right now what I'm looking for is, did you get the right end behavior? Did you get the right x-intercepts? When you look at those x-intercepts, is it doing the right thing? Is it going all the way through it, or is it bouncing like we said it should? That's what I'm looking for on these sketches. Kind of like a sketchbook. You're never going to turn in sketches as like a finished art project. You're just getting a basic idea of the shapes down. That's what I want here. Basic idea of the shapes. You guys ready to try another sketch? Okay. What is my degree? 2. How do you know?
There's 2 factors.
There's 2 factors, and they each have an exponent of 1 on them. They always are going to have an exponent of 1 on them unless I see another printed number there. So my degree is 1 plus 1. So that gives me 2. Jan, does that mean it's even or odd? Even. Leading coefficient. Negative. How do we know that again?
There's a negative sign.
Right here. Here's my leading coefficient. Where are my zeros?
-2, 0.
And 6, 0. How do we find those again?
Single outputs.
Yes, x plus 2 equals 0. Factors are always equal to 0. I get the x all alone to find my x-intercept. So what will my end behavior be here? What'd you say? Positive infinity? Negative? My choices are negative or positive. Why? Leading coefficient was negative, and that determines which side? The right side, which is this one right down here. Here's my right side. It's going to be positive because of that positive leading negative, my bad. Negative leading coefficient. Yep. Leading coefficient, and it's always the right side down here. It always tells me what the right side is doing. So what's the left side doing? Same thing. Why? Because it's even. All right, let's get our sketch. What do I put on the graph first? X-intercepts the roots. -2 and +6. They both should be pointing down. Any bounces right there at the x-intercepts? No. So it should go straight through, and then I just need to connect them. My sketches are really rough on purpose. Yours don't have to be as ugly as mine, but I do want you to understand that these don't have to be pristine. This is not the same as when I have you do the t-tables and the graphing on tests. This is basic shapes. Let's look at the next one down. What's different about this one? It's not factored. They want me to put it in factored form, don't they? What do I always look for first if I want to factor something? I look for a GCF first. Do we have a GCF here? 4 goes into both of them. So I'm going to take a 4 out of each piece. F of x equals 4. What would that leave me with then? I have a -25. What else is in there? X squared. Whenever I see an x squared, this is quadratic. So we need to factor this. How many terms are there here? Just 2. Do I need to use the x and the box if there's only 2 terms? No. This is one of those special situations. This is a difference of 2 squares. How many factors will I get from a difference of two squares? 2. What will be the only difference between those two factors? They won't be squared anymore. That's something that they will both have in common. What will be different about these two sets of parentheses? Yeah, one's going to have a plus sign in it, the other's going to have a minus sign in it. How do I decide what goes in there? Yep. Take these terms and square root them. What's the square root of x squared? X. We're going to put that in both of these. And then I do the square root of the back piece, 5. That goes in both of these. There's my factored form. What's my degree? 2. Is that even or odd? Even. I could have answered that all the way back at the beginning because my biggest exponent was a 2, and 2 is even. Is the leading coefficient positive or negative? Positive. Where are the zeros? Negative 5, 0, and positive 5, 0. How do I decide what the ends are doing? Leading coefficient tells me about which end? The right side. So I look at this. This is a positive number, and so that means what? Goes up. Positive infinity. What'd you say, dear? It's even, so they both go up. Let's sketch this guy. Positive and negative 5. What are my ends doing? Going up. Are they going to bounce right at the x-axis or go straight through it? Straight through it. How do you know? Yes. Neither of the factors are double roots. Neither of the factors are squared. Let's do one last one, and we will call it a week. Get ready for break. Flip the page for me. Let's do the degree and even or odd part first. What's our degree? 3. Is that even or odd? Odd. Tell me about the leading coefficient. Positive. Now I need to put it into factored form to get my x-intercepts. What do we always look for first? GCF. GCF can be numbers or variables. This is anything they have in common. What's the biggest thing that both of these have in common? They both have an x squared in them. So I'm going to take an x squared out of both pieces. So I have f of x equals, I bring that x squared out to the front. What would that leave me with? X minus 4. So where are my zeros? Not x plus 4, remember, zeros are ordered pairs. Yep. Yes. I'm going to add 4 to both sides. X equals 4, so there's one at 4, 0. The other one, I take this x squared and set it equal to 0. What number times itself gives me 0? 0. So x is 0. So that is 0, 0. Talk to me about the ends. They point in opposite directions. What is the right end doing? Going up. So positive infinity here, but on the other line we're going to put negative infinity. Odd, so opposite. Get the zeros graphed. I've got one right here at the origin and one right here. Right side does what? Goes up. Left side goes down because it's doing the opposite. Do either one of these bounce?
Oh, wait, yes.
Which one? Look at this guy. 0, 0. Bounce. It does not go all the way through there. It's going to come up, touch the x-axis, and it's going to bounce off of it. Here it goes all the way through, and then I just need to connect it. All right. Homework number 3 for this unit is due tomorrow morning. I will take it anytime over break, but I have it set as being due tomorrow morning so that it shows up as a missing assignment if you don't do it. Because I don't want anybody waiting until Sunday night and then all of a sudden Canvas tells you that it was due and you're like, oh, shoot. And you don't remember any of it. Please try to get that knocked out. I hope you guys have a fantastic and very restful, much-deserved break. We only have 3 weeks of school when you come back, and they're not even full weeks.
What you mean?
That last week of school is when we take finals, and you guys go Monday through Thursday. You don't have school that Friday. So we only have 2 regular weeks of school when you get back. We're going to finish up Unit 6, and then we're going to review for your final exam. That's why we're not doing a test over this before the final exam, because there's just not enough time. Yes, sir.
The final exam is all of the units, right?
Final exam is all of the units. We will spend 1 day reviewing each of the things that we've studied. But Unit 6, like, look, we just reviewed factoring. That's something that we learned earlier in the year. All the concepts that we've talked about earlier in the year, we will review again. A lot of them get covered in the rest of the Unit 6 material. But we'll still spend a day talking about each piece. Your final exam in here will be the last day of finals, Thursday, the 16th. It'll be the first one you take that day. Sorry. I'll give you more details as we get closer as far as what you can expect.
To get my brain going for, man.
Well, then I suggest you set yourself an alarm that day and do some jumping jacks, drink some coffee, have a big breakfast.
Wake up early.